I'm Beth Pariseau, Senior News Writer at Informa Tech Target, and this is IT Ops Query Season 3, Observability in the Age of AI. Steve Koelpin is a seasoned engineer and award-winning data strategist, specializing in observability, logging, and data pipelines at high scale. With over a decade of hands-on experience transforming complex data environments, he has led initiatives across multiple Fortune 50 enterprises, delivering high-efficiency architectures that reduce spending and elevate operational clarity. He is an 8-time Splunk Trust MVP, a community-recognized expert and thought leader, and the recipient of the 2023 Splunky Inventor Award, honored for groundbreaking innovation in creating self-service tools. Steve has also delivered more than 6 conference talks, built production-grade capabilities adopted across industries, and continues to push the boundaries of automation, AI-driven root cause analysis, and data pipeline optimization. Welcome, Steve. Thanks for joining us.
Yeah, thanks for having me.
So, in the realm of AI-driven root cause analysis, in your considerable experience, how have you seen AI affect observability over the years? What's the good, bad, and the ugly there?
Yeah, sure. So I've seen it, let's start with the good. And I've seen it beneficial in a few places. I would say number one is going to be the noise reduction. So AI giving you the ability to consolidate a bunch of noise or alerts down to a single actionable alert, which you can investigate. An example of this is, say you have a 3-tier system where you have a database, an app tier, and a web tier. Say the database fails, everything's going to be dependent on that database to serve traffic. If it's unavailable, everything else is going to fail. So you have a lot of upstream noise or upstream tickets that will be generated because of that failure on the database. So you could be flocked with hundreds or even thousands of incidents, and you're not really sure what to troubleshoot first. Having the ability to correlate those together into a single actionable alert and then look at what went wrong first within that single actionable alert helps you reduce your MTTR.
An MTTR, for the uninitiated, is mean time to recovery.
Yep. Big metric they judge on is MTTR. I would say the second benefit or the good within AI for observability is achieving the holy grail of predictive insights. So something teams have been struggling to get for a long time. It ties back to the MTTR we were just talking about, Beth, where you want to shift left. You want to try to reduce your MTTR, mean time to resolution, to solve problems. You want to shift that left. And they think about where if you shift left enough to where you can shift into the future. So you have the present, have the past, and then you have the future of when a problem comes. So might not be much, but getting a 5, 10, 15-minute head start of something's going to go wrong. This is a reasoning of why the AI thinks it's going to go wrong, and alerting teams and potentially avoiding that problem before it occurs.
Okay.
Lastly, I'd probably say the root cause acceleration would be the last good that comes out of this. So having the benefit of correlating multiple metrics or multiple things together to make a conclusion faster than what a human can typically do. If you think about standard operating models, you have L1, L2, L3. Your L1's typically 24/7. They have all eyeballs on dashboards. They're the triage team. So they triage based off knowledge articles. So having the ability to remove the human and put in a model that can do the basic triage, it can solve problems based off knowledge articles or make suggestions or aid the L1 into triaging without escalating upward to L2 and L3.
But it can't all be wine and roses.
Oh, no, definitely not. So this is where the bad and the ugly comes into play. I would probably say the bad would be the black box model of this. So the inability for engineers to understand how it all works is just a black box, and you trust what it says, even if it can lead to bad things that we'll get into in a bit. But ultimately, trusting something that you're not quite sure of how it works could lead to catastrophic problems. I also think the overhype is bad too. People are rushing to AI. It kind of reminds me of the dot-com boom back in the early 2000s, where if you had a dot-com website, you were in it. And this is really what it reminds me of a lot of. I'd say the ugly now, alert dependence. So back to that black box aspect of what we were talking about is teams, they become reliant on it. You lose the curiosity of engineers. You need engineers to understand how things work. The second that they start trusting a model to show them how things work is when you're going to run into disastrous problems because they lack that problem solving ability and they become too dependent.
Right. It's great till it stops working.
Yeah, exactly. And really the data bias too is another big problem. So if you give it bad data, you're going to get bad results.
Yeah.
Fundamentally speaking, so you have to have good, clean data that you feed into it. And really, lastly, you want to avoid that vendor lock-in too. Of some proprietary vendors will get you so far into their platforms where it's hard to get out.
Right. And then so many engineers are having to manage and operate AI apps themselves because everybody, like in the .com era, everybody has one.
Yep.
So what role have you seen observability play in taking on those apps?
Yeah, great question. So I think monitoring the AI apps is going to be one of the key things, right? So understanding not only is it working, but is it working properly? So getting that visibility into model behavior, I think is going to be huge. So you can't really trust it in terms of, you don't want to trust standard metrics like you once did with data in terms of monitoring uptime. But I think going a little bit deeper and understanding the drift or the hallucinations and really reducing those. And we'll go more into that, but super important that you feed it good data, you reduce the hallucinations, you reduce the drift, you continue to update it, and really getting visibility. Is it working? Is it not working? And I think once you build that visibility tier, creating that monitoring aspect throughout your pipeline. So not only AI is not, it shouldn't be thought of as just an independent solution of itself, but more to complement your existing solutions that you have. Your logging platform, your observability platform, your security lake, your data lake, et cetera.
Does operations run into that black box problem with monitoring their own company's AI apps too? How do they get around that?
I think it's common. I think it's common to lack understanding or lose vision for what you're doing and gaining too much dependence. I think it's definitely a common thing. And I think it's important to have good, competent engineers who know how it works and has an understanding overall of how everything works and what happens if it were to go away. I think a really good analogy is GPS. I'm terrible with directions, and I've gained so much reliance on GPS to where I couldn't find my way around, especially in a foreign city, without it. I'm dependent on it. So breaking out the map was something I could do back in the day, but I have limited ability to read a map now like I used to, and I rely solely on the GPS.
So how do you get around that in an enterprise team? How do you counteract that effect? Or do you?
Yeah, I think preaching and understanding that you can't trust the output of the model. You need to question things. You need to be an engineer. You need to have that curiosity. Going deep into it, not just trusting the process, but questioning the process. Did this give the right output? And anytime that it didn't give the right output or it's clearly hallucinating, why did it hallucinate? Understand your type 2 errors and address them and fix them and shorten that feedback loop.
And then, ready or not, here come AI agents. Is that something you've started to work with, or have you seen how AI agents might change these dynamics?
Yeah, I'm really excited about AI agents. So I'll give you one example where I've seen a lot of development on this. That comes in forms of dashboards to decisions. So before you needed eyeballs on the dashboards at all times or eyeballs on glass, 24/7, you have a lot of offshore, nearshore teams that do that basic monitoring. They do that basic triage. They look at dashboards, any type of change in the dashboards. They go read knowledge articles, and they take action based on the knowledge article. They triage, they escalate if needed. Having the ability to remove that human from that monitoring tier and having that agent represent the human, but be available 24/7, they have the ability to rapidly read through knowledge books. They have the ability to rapidly understand information, fire off automated jobs, and potentially resolve problems. One example that I could potentially see this being useful, a lot of logging tools leverage workload licensing pretty heavily. If you think about humans in general, humans, they're relatively lazy in terms of finding the fastest route possible to get problems solved. So I'm not saying it's a bad thing. It's good to be efficient. But what I am saying is they typically take the easy route. And if you think about when scheduling a job, they typically pick the pre-built schedulers, which are typically top of the hour, every 15 minutes, every 30 minutes, every 45, et cetera. They're predictable. So a lot of that workload licensing, you'll see a lot of violations that occur right at the top of the hour during peak time. So 1 o'clock, 2 o'clock, 3 o'clock, etc. The next busiest times you'll see is right on the half hour. Everybody wants to run alerts every 15 minutes, every 5 minutes, every 1 minute, every 1 hour. All of that coincides at the top of the hour. So you have massive distribution of heavy workload right at the top of the hour, which typically results in license violations, performance degradation, having to buy more licensing to overcome that. Where if you look, say, 5 minutes past the top of the hour, you see a massive trough of drop off of people not searching, job searching. Even 7 minutes past the hour, 11 minutes past the hour, very uncommon times that people typically don't schedule things for. So what I can see potentially happening in the future, these AI agents going in there and redistributing. So looking at bad configurations now and saying, I see so much misconfiguration at the top of the hour at the 15, I'm going to go ahead and reset all of this and level the load and reduce your license usage and optimize your license based off just what I see. So that's really a big one that I see. I also see, if you think, I don't think they're that advanced yet in terms of models, I should say, are solving problems. So I like to think of them as like an intern or a junior SRE on steroids. So they can solve basic problems. They can triage. They can button up something to where like an L2 or an L3. As an L3, I don't want to waste my time looking into the basics or starting from scratch to try to identify a problem. I would prefer it go to L1. I would prefer they potentially try to solve it. And if they're unable to solve it, they document what they've tried, what they've looked into. Have they tried everything that they've read from the knowledge article? If they can't try anything else, document your notes, escalate it upward, pass it to an L2. And if the L2 can't fix it, pass it upward. That takes time. So sometimes it could take an hour. Sometimes it could take 3 or 4 hours before the engineer even looks at the ticket. So having the ability to do immediate triage, can the AI agent solve the problem quickly before it escalates up? And if it can't solve the problem, it picks it up, it does the triage, it escalates it up rather than sitting on a ticket for hours at a time. You can resolve problems faster.
Does it make that dependency issue worse?
I think it potentially could, but I think it's a balancing act, right? I think with these new technologies coming in, I think you need to continue to understand how it all works. I think you need to continue putting things together and trying to optimize inefficiencies with AI wherever possible.
Right, because the data is not getting any smaller. Apps are not getting any less complicated.
Not at all.
Along those lines, you've had a lot of experience in managing data at very high scale. I think a scale that many people are newly encountering these days, especially as you alluded to the importance of good data management in AI. So what have you learned about do's and don'ts for managing high scale data?
For managing high scale data, I'd say there's a few things that are important. I would say number one, treat your observability as data management. So there's logs, metrics, traces. You need to think about how you can integrate all of that together you can correlate all that together into actionable insights. So obviously you want to automate your data hygiene. You want to tag it as much as possible. You want to normalize it into a standard schema wherever possible. And you want to route that data too. So the big thing I'd also recommend is use pipelines to enforce your schema before it hits destination. You want to reduce volume. You want to enrich the data while it's in flight. You want to tag it. You want to add lineage tags to it. You can easily troubleshoot it that way. Tagging your data to identify lineage, I'm telling you, it's dividends that pay off again and again over time. And it enables you to depollute that downstream system. I think another big advantage is to leverage retention and strategize your access policies. So a big one here is tier your storage. Storage, not crazy expensive in terms of a lot of this licensing for workload, but I think it can get expensive when you start dealing massive scale. And I think at lower scale, it's typically an afterthought and you can buy your way out of these problems. But when you start hitting petabytes and petabytes and petabytes worth of data that you have to keep around for multi-years at a time, I think it becomes quickly a problem. So tiering storage, having the ability to assign different values of assignments on types of data. So some data is more important than other types of data. I would say new data is significantly more valuable than older type data.
Yeah.
For example, one exercise that I go through a lot is whenever I would go to customer sites as a consultant, one thing that they would complain about again and again is I'm over my storage usage. How do I just stop having to continue to buy more storage, and how can I optimize what I currently have? And so I think one important exercise I do is going through the audit logs and see what users are actually searching against and what their lookbacks look like. And I would say a majority of the time, users aren't really searching beyond 60, 90 days worth of data.
Mm-hmm.
Very seldomly do they search beyond that. A vast majority of the searches are going to happen within the first 7 days, while even more so, a vast majority is going to happen within the first 24 hours of that data. As that data begins to age off, it's not that important anymore, but it may still be used and it has to be kept, which ties me directly into my strategy around mastering the capability of rehydrating your data from cold storage or non-searchable storage back into searchable storage. So if you think about the cost considerations, you're looking at maybe a 5 to 10x decrease in cost in terms of non-searchable storage versus searchable storage. So going in and getting insights based off the audit logs of what users are actually doing in the platform, and then identifying, are they really searching it, and then freezing the data. And then if they ever did need the data, reduce the friction to go ahead and rehydrate their data, make it searchable again, and allow them ease of access to get access to their data, and then freeze it off again. If you can master that one capability there, you're going to be looking at significant savings within storing high scale data.
And in another lifetime, I was a reporter I was covered storage. And I am probably dating myself with this question, but is data deduplication still a thing, at least for that long-term storage? Yeah.
Yeah, it absolutely is. And I'm glad you brought that up, Beth, because if you think about data in general, having the ability of setting up that observability pipeline is so critical in today's age.
Mm-hmm.
If you think about all these vendors that come into play, you have Splunk, Datadog, Elastic, all of these vendors coming into play, they're proprietary solutions. So when you pick a vendor, you're typically locked in for several years at a time.
Mm-hmm.
So when you decide to finally make that move, what happens when you have petabytes of data sitting in that vendor's proprietary logging solution? It's not good. They typically won't let you get it out. And the way most companies deal with this is they have to let it age off and they have to own both solutions concurrently. It's not a good solution. So I think really having that observability pipeline in place, which represents your intermediate forwarding tier. So your sources will send to that tier. And then you can fork a copy of that data, untouched, immutable data, to cheap object storage. And then you could aggregate or just fork an identical copy to your logging solution. And if one day you say, you know what, I don't want to use this logging solution anymore, you have a copy of all of that data sitting in cheap object storage, non-searchable storage. Yeah, you're paying money for it, but it's next to nothing in terms of keeping that data. And it's also next to nothing in terms of licensing to go to another vendor and being able to retroactively rehydrate that data sitting in cheap object storage into the new vendor tool without having to eat the cost of two concurrent tools at one time.
Right. And so that dedupe, now that happens in that data pipeline?
Yes.
Yeah.
Yes. So I should have addressed that. But yes, that data pipeline is going to do a lot of that deduplication.
Mm-hmm.
It's going to do a lot of enrichment. You can flatten a lot of JSON logs. It can unroll XML. It can transform them into clean key value pairs. So rather than having this nasty XML file that could be just gigs or megs long of just like within like say a minute of data, you can transform that by getting rid of a lot of the junk, deduplicate, tag it, normalize it, convert it to OCSF is a common framework for security these days. Taking a lot of that garbage and transforming it into clean key value pairs, as you said, deduplicate the data and push it into whatever pipeline you want. What if you want two destinations to do the evaluation? You can push one feed to cheap object storage. You can have an immutable raw copy of that data. You can push a schema-sized version of that data to more object storage, or you can push it to two other tools or one other tool. So having that observability pipeline sit in the middle and route your data as air traffic control and transform it, I really think is a critical capability.
Right. And You also mentioned data lineage. How does that, can you tie that back to data management for AI and observability? How does data lineage help you?
Absolutely. So the big problem that we ran into back in my consultant days was you have all of these distributed systems. You have a lot, if you work for a larger company, you're probably dealing with a lot of mergers and acquisitions, a lot of non-standard data sources coming in, a lot of non-standard naming or different standard naming.
Mm.
So if you set up the data lineage now, the benefit of doing it within your observability pipeline rather than doing it at source or destination, number one, you have that layer of standardization across different M&As, acquisitions, whatever it may be, and identifying where it came from, what network did it come from, where was the original source did it come from. Sometimes things may be lost in translation. So when it hits your destination, it may have hit two or three different systems. It could have been going through an aggregation tier, which a bunch of stuff got jumbled up and pushed together and pushed outward of a firewall. So the data traverses many hops before it hits its final destination.
Mm-hmm.
So having the ability to understand where the source was, where it made each hop, and then if that data source were to ever break, having the ability to trace it back step by step to identify its lineage is going to be super important. And the other benefit of data lineage is having the ability to conditionally tag your data within the pipeline itself. Such a super powerful capability, because when you start applying good standard tagging, and it can be all conditional, particularly against data lineage, you can start routing efficiently and effectively. You can start aggregating up and you have much more control of your data.
Let's say somebody is starting right now with that data classification and management. Is it better to just start with the new data, start keeping those practices, or is it better to go back and revise how older data is stored?
Yeah, good question. I think it's an uphill battle to revise older data sets. And
Mm-hmm.
as I said prior, data loses its value significantly as it begins to age. It's kind of like a used car
Mm.
where it's highly valuable until you drive it off the lot. And the second you drive that used car off the lot or even the new car off the lot, depreciation sets in.
Mm-hmm.
Identical scenario with data. The second that data hits the wire before it's scanned, very valuable. The second that data gets scanned, or it goes through dashboards, or it gets scanned for alerts, reports, et cetera, it gets summarized, that data significantly loses value over time. So
Mm.
if you think about data that's non-standardized or non-schematized or older data sets, yeah, I think it's important, but I don't think the juice is necessarily worth the squeeze in terms of trying to reformat that data. I think it's good to go ahead and do it from this point forward. And then ultimately, if you have some project or something you're going after, it's important to say, we want to start at this time after the new data sets have been flowing, and then essentially let the old data that's unschematized age off.
So, what's the next frontier for you in terms of AI and observability? What challenges do you think you'll be taking on next?
Yeah, I think that's a pretty good question. I think AI observability is a really interesting topic.
Mm-hmm.
I think if you think about the old days of the mom or the manager of managers, you want some type of observability or monitoring based on how your agents are performing.
Mm-hmm.
So, what decisions are they making, whether they're causing drift or harm? And this leads me down a really good point of fighting entropy.
Mm.
One thing that anybody working with data or anybody working in operations or anyone working with AI will understand, entropy is a naturally occurring thing. It's going to drive a lot of drift in your models. And if you think about what entropy is a naturally occurring thing, which essentially causes orderly to disorderly. So say you train a data set on orderly type data, good schema sized data. And over time, you may lose some of that schema. You may change the schema, or you may have dirty data that got put into the system.
Mm.
And because of that dirty data, times were different when you initially did the training than they are now, which leads to drift. And if you think of drift, it can lead to hallucinations. So the number one cause of hallucinations is drift. And ultimately, hallucinations for the uninitiated are when you get confidently wrong answers within your AI models.
Mm-hmm.
And when you start building feedback loops or automated actions based off that AI intelligence, it starts causing problems. And if you think about like confidently wrong, you ask it a question in terms of like, how's my health on X, Y, and Z server? If it hasn't been trained on that data, or if it's getting bad input coming in because you have short feedback loops that are feeding it, ultimately it's going to say, oh, this thing's very healthy, when in reality it's down or it's not processing transactions.
Right.
And so hallucinations are a major problem.
Yep.
And that's one area that I definitely want to get more into, is how to reduce hallucinations, how to fine tune these models, and how to get good monitoring on your AI agents.
Right. Is there anything you found so far that seems promising?
Yeah, there are a few things. I think the predictive analytics is getting a lot better. It was significantly harder back in the day to reach the holy grail of predictive analytics.
Yeah.
I do see a lot of promise there. I do see a lot of promise in single actionable alerts. I see a lot of promise in reducing the entry barrier for people using these tools and getting value. I see a lot of promise and advantages for a lot of senior engineers to do more with less, to solve more problems, be more efficient in their time, and get more output. Yeah, there's a lot of benefits I potentially see, but I really think we got to weigh the good with the bad and try to not be dependent on it, but be smart about it.
Right. Okay, so that was everything I had in mind to ask you, unless there's something else you wanted to mention.
Yeah, there's really one other thing too that I want to mention. It's about cost.
Sure.
Cost is probably the number one driver of decision making for tools, other than the value. And to be honest, I think cost probably exceeds the return on investment and the value it can provide. Everybody's cost conscious, except for some of maybe these larger players who have unlimited budgets that need the value. But if we think about controlling cost at scale, there's a few things that I would highly recommend. Filter at the edge before it hits storage. Drop the noise, cut your ingest 30, 50%. Like I mentioned earlier, you have that XML file. And the way I like to think about it is like DNA, where only a tiny portion of that DNA is actually usable, where a majority of it's just junk, but you need it still. You just can't throw it away. You still have to keep it. So having the ability to filter out the edge, transform, store unlikely to query but needed data into cheap object storage, paying a little bit for it on the off chance you may need it, and then extracting insights from that massive amount of data. If you think about like an XML, just like a big wall of content, and then extracting out key value pairs and getting rid of everything else. That's a huge thing. I think normalizing and reusing everywhere is going to be another big thing. Don't put walls of text or data in multiple tools. Store it, the immutable copy, in your cheap object storage, which precedes it hitting your destination. Transform the data, clip the data, and land the data in your destination, whatever's needed. Other big one too is just decouple your data pipelines with your logging tools. So a lot of customers, or companies I should say, typically get in the weeds because they buy the observability tool that the vendor supplies where the data lands. Decouple all of that. Have an agnostic routing tool which allows you to have control about where your data goes. This gives you a lot of power in negotiations with vendors. Having the ability to, when it comes to renewal, not accepting what they demand, but having the ability to say, I'm going to go to this tool because they're coming in way cheaper and I can get more value. And I don't need your logging. I don't need your pipeline to get my data there. I have my own pipeline.
Right.
So I cannot stress that enough.
Good advice. All right. Thank you so much, Steve. I really appreciate it.
Yeah, absolutely.
This has been IT Ops Query Season 3, Observability in the Age of AI. If you have any feedback on this episode or want to share questions, comments, or stories we should consider covering, please reach out to me at beth.pariseau, that's PARISEAU, at informatechtarget.com. Please consider rating, reviewing, and subscribing to this podcast on your platform of choice, and tune in next week for our continued conversations with industry experts about how observability is shaping AI and how AI is shaping observability.